We're going to talk about sensible and latent heat a little bit more. Here is a drawing of an evaporative coil. Of course, it doesn't look like something you'll see, but it's a good representation. This red line here that turns into blue is the air from the fan that's blowing your home air through the coil, and this is the way the coil gets heat. Your room temperature air has BTUs of heat in it at 75 degrees, and as long as the air in your room is over, say, 40 degrees, your air conditioning will continue to cool properly, or at least it will continue to change the temperature of the air. So what this shows is there's a gauge down here that says this is 69 psi. This is R22 refrigerant, 69 psi, and it's about 40-degree temperature. As it goes to the reading device, it sprays a little bit of refrigerant in here. The refrigerant breaks down between somewhere in 75 to 25 or 80 to 20 liquid and gas. So it's going to be 80% still liquid, but the gas is going to be flashed off. It's going to be considered flash gas because it goes into a bigger area. So automatically it's going to expand. As this liquid is running through this coil, it is taking a little bit of the heat off the 75, a few BTUs off the 75-degree air. The air is changing temperature as it goes through this coil because the heat molecules on the air are actually transferring to the cold copper/aluminum type coil that's considered the evaporative coil. So as this 40-degree refrigerant runs through here, remember I said that earlier that the refrigerant boils off at 40 degrees. I know that's hard to believe, but water does at 220 or 212, and other items boil off at different temperatures. But R22 boils off at 40 degrees. So as it's going through here, it's taking the saturated heat from the air, room air, which is 75. Again, it's got to be over 40 to do something. So as it's going through here like the pot, the air is just starting to heat this refrigerant. Well, when it gets to that temperature where it's 40 degrees and it starts bubbling inside this copper tube, it's just bubbling away just like that pot was boiling, it's going to accept more and more heat. So when it hits latent heat and it starts boiling, it will accept more and more heat, more than it did down here. When you see the change in color here, it's going from a dark blue to a lighter blue. This is accepting more and more heat, and until it gets out of that latent heat stage, where it's changing from a liquid to a vapor or a gas, it's going through and it keeps changing. It stays at 69 psi, and it keeps running through and accepting more heat out of the air, more heat out of the air. That's why latent heat is so important, because it absorbs like 150 times more heat than sensible heat. As we saw in that pot, the heat doesn't matter how hot you got that pot. 500 degrees, that water stayed at boiling temperatures, 195 to 212, depending. His thermometer wasn't working very good. But that water is at 212. No matter how hot that pot can get 1,000 degrees, and that water is going to still stay at 212 because that's the latent temperature. So as this refrigerant gets pumped by the compressor through this line, it's accepting more and more heat, or BTU heat, from the air, and it's changing its state. Now it gets to this point, now this is all vapor, and it's no longer a latent heat. It's accepted about as much heat as it possibly can. It's still cool, it's still in the 50-degree range, and it will still be taking heat, but now we're back to sensible heat. It's not changing state. Again, to have latent heat, it changes a state from the liquid down here to the vapor up here. So now this is just a gas at this point, just like the steam coming out of the pot, making through the line, going back to the compressor to start the cycle all over again, to where it's still 69 psi, but now it's 50 degrees because there's been a change of state from liquid to vapor. That's latent heat.